This is the first section of Chapter 12, Sequences and Series. Today we're going to look at arithmetic sequences. We're going to start with a few definitions to get us started here before we move into looking at actual sequences and how we can use them and how we can find certain terms of them. The first definition is sequence. A sequence is a list of numbers or objects in a special order. We're mainly going to be looking at lists of numbers where we can try to figure out how can we find the next number or the next four numbers in the sequence. A term is that number or is that object that's in the sequence. So when we have a sequence that looks like this with different numbers, each of these is a term. So it's really the individual pieces that make up the sequences. If you're looking at an arithmetic sequence, it's a sequence made by adding a value each time, and this value is consistent. It's always the same value that's added to get to the next number. And the common difference is the value that's being added each time. So in an arithmetic sequence, when you go from one term to another to the next, we're going to add something each time. So if we had the sequence 2, 4, 6, 2 would be a term. This would be an arithmetic sequence, and our common difference would be 2. So it's how do we get from one to the next? We add the number. On example 1, I just want you to find the next four terms. You don't have to do anything crazy yet, but just write down what those next four terms would be. Looking from term to term, the first term to the second term, it's a difference of 6. And more specifically, -6. So if we took 43 and we added -6, we would get 37. Likewise, if we add -6 again, we move to 31. We add -6 again. We add -6. This is the same thing as subtracting 6 each time. The reason we want to use this -6, though, is because the common difference is what we add to get to the next term. So our common difference here would be -6. So our next term would be 13. Our next term would be 7. Subtracting 6 again would give us 1. Subtracting 6 again would give us negative. So it's quite all right to go from positive to negative. That's where the sequence takes you. Likewise, we can go negative to positive. We can start with a negative, and then from each term we add, in order to get to a smaller negative number, and we add 0.9, and then we add 0.9 again. So if we add 0.9 to 0.2, we get 1.1. We add 0.9 again, we get 2.0, 2.9, and 3.8. Okay, so our common difference here would be 0.9, positive 0.9, and our common difference on the top one would be -6 because it's what we're adding each time. So that's kind of the basics of it. That's probably things that you've seen for a couple of years now. Now we're going to get into more of the Algebra 2 portion of it. The first key concept, it says the nth term, which is represented by a to the n, or a sub n rather, of the arithmetic sequence with first term a sub 1. So this subscript right here always tells us what position. Okay, first term is a sub 1, second term would be a sub 2, and then if we have an nth term, you have a sub n. So if we have the first term and we have a common difference, which is d, it's given by the formula where n is any positive integer. All this is saying is that we have to move from the first, second, third. We're always using a positive number when we're talking about the location, the position of this number. Okay, so here is the formula. This formula actually makes a lot of sense. What it's saying is you take the position number, you take 1 away from that, and you multiply that by the common difference. This is going to give you how far away or how many values are between the term you're looking for, which is a to the n, and your very first term. So breaking it down a little closer, defining a few variables here, we have a sub n. This is representing the value at position n. A sub 1 is your first term. D is your common difference. And n is your position. Okay, so the difference between a sub n is the value that's at position n, and n is the position. So moving on to an example. A few things are key here. 1 month is $75,000 for rental. 2 months is $90,000. 3 months is $105,000. So if we really wanted to, what we could do is we could write these out. We could write them out in a sequence, and we could say if we continue the sequence, and we could continue it and find position 12, we could very easily find that number. But if we're looking at, what about 4 years down the line? Well, if we have to rent it for 4 years, then this is going to be extremely difficult, and you're going to end up listing a ton of numbers. So what we want to do is we want to use a shortcut and use this formula that's going to help us very quickly figure out how we can get this 12. Okay, so our common difference, D, is the difference between these. So it is $15,000. Okay, it's positive. So if it was decreasing here, this would be negative, and we would definitely want to take a negative. But since it's increasing each time, this is going to be positive. So we know that D is 15,000. We're looking for A sub 12 because N was our position. We want the 12th position. So that means A sub 1 was our initial. So we have 75,000 plus 12 is essentially N. So you may want to define that because then you have 12 minus 1 times your common difference of 15,000. And we set it up. So all we've done is we've substituted an N value and a D value in along with our initial value in order to solve this. So now doing some math, we can simplify this down to our answer of 240,000. And the last thing we always want to do is we want to say, did it increase? Yes. Does 240,000 seem reasonable for 12 months? Yes, it does. So we can check our answer here. At this point, I want you to hit pause. I want you to work this problem on your own, and I want you to hit resume when you have finished. Go. One thing I failed to mention is that this problem is closely related and uses the same numbers from the previous problem, so go ahead and make sure that you are using those values when you complete this one. Essentially what this question is asking you is to find the value or find the amount it's going to cost to rent in 18 months, and then you're going to compare that to 350,000 and see will they have enough money. So all I've done here is I'm trying to find the 18th position, and what I end up doing whenever I multiply this out and figure it up, I end up getting, and again I'm skipping a few steps here, that it's going to cost 330,000 to rent this for 18 months. So comparing that to 350,000, they do have enough money, and I do want to show that because that's what the question's asking me. All right, example 3, we're going to write an equation for the nth term here. We're going to be given a sequence, and we're going to take it upon ourselves to write the equation. So what I would start with here is what A1 and D are, because we know what those can be in our formula. So A1 is going to be 8. Our common difference here from 8 to 17 is 9. From 17 to 26 is 9, and it's positive 9, so it's a positive 9 here. Other things that we need, so for the nth term we have A1 plus N minus 1 times D. Okay, since we're looking for the nth term, we're not too concerned about this N. We're looking for A to the N equals, we substitute our items in, times our common difference of 9. And now what we want to do here is we would want to multiply this in, distribute it in, we get 9n minus 9. So if we really wanted to complete the formula and really simplify it, we would have 9n minus 1 for any term. Okay, and a great way to check this is to go back through and say, what if I'm trying to find term 3? Okay, this is when n is 3. So I take 3, I plug it in, because that's my position number, n is my position. So 3 times 9 is 27, minus 1 is 26, and sure enough, it works. So when you're writing the equation, you should be pretty sure, about 99.9% sure that this is right. Okay, for the next one, I want you to hit pause. I want you to complete it in a very similar manner. Realize here that you are going more negative, so you are subtracting each time, so your common difference should be negative. So go ahead and hit pause, complete it, hit return when you're ready. So your common difference here is negative 2 because it's what you add from one term to the next. And then your initial number is negative 1.5. So what we want to do here is we plug it in. we get negative 1.5 plus n minus 1 times the common difference, and that's going to give us any number that's in position n. So again, we want to simplify this. We get plus negative 2n plus 2, and we further simplify it, and we end up with 0.5 plus negative 2n, or minus 2n. I'm also good with that. And you can double check that by plugging in certain positions to find it. Okay, here we're going to use this formula again, and we're going to be given some information, and then we're going to be able to find what the common difference is. So we're going to use the same formula. So make sure you're getting used to it. Here the first term is 16, so I'm just going to plug in what I know. At this point, I don't know what n is. I'm looking for the common difference. Okay, here a to the 6th. I'm going to use a to the 6th, so n is 6 here. So what I'm going to do is I'm going to say a to the 6th, or a to sub n, or rather, is 91. So that means that 6 is n, and now I solve. So I continue on. It's 5d. I subtract 16 from both sides. I get 85, and then I divide, and I get my common difference to be, the common difference will be 17. So a great way to check this is to add 17 each time and see, when I do I get all the way to 91? So basically all I did was I plugged in information that was given to me, and I used that to find the common difference. Okay, when it says 3 arithmetic means, what we're saying here is we're starting with 15.6, 1, 2, 3 means in between it. So this is how you're going to set up the problem. I want you to complete this problem, and then, so hit pause, complete it, and then hit resume in a second. Here's my work, much like the last problem. And all I'm going to do now, once I've found the common differences, I'm going to take it one step further, and I'm going to find these 3 numbers. So I'm going to add 11.2 each time in order to find my missing numbers. So I end up with 26.8, 38, 49.2, and then a great double check, you should be 100% sure if this is right, is you add 11.2 and you should get to 60.4, and you do. I just realized that I made a mistake, so I want you to go back to example 4 really quick. Instead of, when I subtract 16 from 91, instead of getting 85, I get 75. Okay, so our common difference here is actually 15. So using that 15, I find the missing terms of 31, 46, 61, 76, and 91. So I apologize for that mistake. Go ahead and make sure you go back and make that change.